Okay, we have a spherical balloon is inflated with gas at a rate of 500 cubic centimeters per minute. Find the rate of change of the radius in centimeters per minute when r is equal to 50 centimeters and r is equal to 75 centimeters. Okay, to keep this video under 5 minutes, I'm just going to focus on the radius equaling 50. And I'll show you how to do the 75. But I'll just concentrate on the 50 part. Okay, so this is a related rates problem. Okay, we want to think about some kind of a relationship. In this problem, there's a formula for volume of a sphere. So volume of a sphere is volume V is equal to 4/3 pi r cubed. Okay, then from there, you're going to find the derivative of each side with respect to time. Okay, with respect to t. So the left side, the derivative of v with respect to t would simply be dv dt, okay, which means the change of volume with respect to time. Okay, the derivative of the right side. Okay, when you're doing this, notice 4/3 pi is just a constant. So when you have a derivative of something with a constant in front, you just write down the constant first, 4/3 pi. Okay, times the derivative of r to the third. The derivative of r to the third is 3r squared, but we got to put a dr dt after it. Okay, dr dt. Okay, before I start using this formula to plug in what I know and find what I don't know, I'm going to go ahead and clean this up a little bit because I know 4/3 times 3 is just 4. So I have dv dt is equal to 4 pi r squared dr dt. Okay, now let's think about what we can plug in. Okay, so the first thing they tell us is the balloon is inflated at 500 cubic feet per minute. Okay, that's the volume change. That's the change of the volume over time. So that's dv dt. So that 500 goes there. Okay, 4 and pi are just constants. Okay, the radius, okay, well, that's part A. I'm going to call that part A, where they say when the radius is 50. So we're going to put 50 in for r. Okay, now this dr dt, that means the change in radius per time. But look at what they asked. They want the rate of change of the radius. Okay, so that's what that means. Dr dt is the rate of change of the radius. So that is the unknown. So we'll just leave it there. Okay, so to find the answer to this problem, all we do is multiply all the constants together. The left side is 500. Okay, on the right side, we can multiply 4 times pi times 50. And I know I approximated, but I got something close to 31,400. You still have dr dt. Okay, so dr dt, to find that, okay, you're going to divide each side of that equation by 31,400. You're dividing both sides by 31,400. And when I did that, I got approximately 0.016. 0.016 centimeters per minute. Okay, so that means when the radius is 50 and the volume is increasing 500 cubic centimeters per minute, that means the radius is changing, is increasing at 0.016 centimeters per minute. Okay. Now, for the second part, the radius being 75, I'm at my 5 minutes already. You're going to go back to this equation right there at the bottom, The only difference is you're going to be putting 75 in instead of 50. Do it the same exact way. Okay, I really hope this helped. I want to thank you for watching the video.